Hello grade 10s. Right, I am working through homework activity 1 now. I am not going to go through each of these answers. I will put pictures up on the group about each of these. I want to keep this video as short as possible for the sake of everybody's data or data, whichever way you want to say it. So homework activity 1, your definitions are straight from your guidelines, page 12 and 13 of your exam guidelines. You should be learning all of those. This is how to draw a bar magnet, and then this is theory, which is straight from your textbook. I've even given you page numbers for some of those. Okay, you can Google Northern Lights or sky in Finland, whatever you want to think, for a visual of what an aurora is and how it is caused by a magnetic storm. There's plenty stuff on YouTube about magnetic storms, auroras, and northern lights. So here is question 8 and 9. Okay, question 9 asks you what happens when a magnet is cut in half. I didn't go through that in the theory. Your original end stays the same. The other original end stays the same, and as you chop it in half, okay, a new north and a new south are made, because those domains that are inside this magnet are still pointing towards this end, which means that there is a new north and now a new magnetic field around there and a new magnetic field around there. Right, now question 10 is the one that I wanted to go through. It's an extremely important question, and it's an exam type question. Often they will give you data just like they've given you information in your textbook and ask you to draw a graph, or they will give you a graph and ask you deductions or information based on this, how to relate it back to mathematical equations and relationships. So what is the relationship? This was an investigative question. Okay, remember your investigative questions always have to start with a question word. They have to talk about the two variables, the dependent and the independent. Okay, and it has to have a question mark. Make sure that yours have question marks, otherwise you get marked down, or sometimes on some memos you don't get any marks. Right, 10b. The distance between the two magnets is inversely proportional to the force exerted on them. This was a hypothesis. This should be a statement. No, I think that, or the magnets would this or that. Okay, you are relating the two variables to each other. Okay, they ask for an independent variable. This is the one that we as scientists change. We are changing the distance between the magnets. The one that is changed based on that is the dependent. So the force between the two magnets relied on the distance between the magnets. Okay, then it goes through your fixed variables. This is what are the things that you have to keep the same. So you would have to use the same magnets for each measurement. You would also have to use the same equipment. Whatever meter you are using, force meter, whatever you're using, to measure that force between the two magnets, you would have to use that same machine so that it is calibrated equally for each of those magnetic pairs. Okay, then it asked you for what happens to the force as the distance increases. The force between decreases. Okay, this is what I wanted to go through with you guys. When you are drawing a graph, you always need to start with an origin. You need an x-axis and a y-axis. You should be starting from 0. You should not be doing a little squiggle and starting from whatever number you like. Okay, it should go up in equal intervals and up in equal intervals. You should have a unit, well, an explanation and a unit, explanation and a unit. What you are measuring should be along that side. And you should always have your title at the bottom. Okay. Right, over here, what I want you to notice from this is that where the force is highest, the distance is lowest. As the force decreases, you can see that the force is going from 12 down to 6. The next reading is 4. The next reading is 3. As the force is decreasing, the distance between them is increasing. So we should actually talk about it in terms of distance, as we are increasing the distance between the two magnets. As we are increasing the distance, we can see that the force is decreasing. Okay, so at 0.5, the force is 12 newtons. At 1 centimeter between the two magnets, the force has dropped to 6 newtons. So as we increase the distance between the two magnets, the force decreases. You can see that this makes a curved shape like that. Okay, so when we see any graph with that kind of curved shape, we automatically know that it is a inversely proportional relationship, where we have got something on this side and something in the denominator on the opposite side. So as we increase the distance, the force will decrease. We could also write it the same way. Force is inversely proportional to the distance. Sorry, this should be a small d. Okay, so that means think about it as something is in a denominator. As it gets bigger, the actual fraction gets smaller. 1 over, if we substitute 2 in here, half. If we substitute 4 in there, it is a quarter, which is actually smaller than a half. So as the distance increases, the force actually decreases. So over here, what this teaches us, this graph shows us that the relationship is inversely proportional. Please stop saying indirectly proportional. Okay, I can only mark inversely proportional. That means when the distance is small, the force is large. As the distance increases, the force decreases. Right, for I, this is done on the graph. You have to find 1.2. They ask you, what would the force be, what would the expected force be when the measurement is 1.2, the distance between them. Find 1.2 on your graph. Read it up until it hits the curve, read it across, and it should be somewhere around 5. Okay, I did draw this to scale. If you feel it's 4.8 or 5.2, anywhere on a 0.2 on either side of that point would be acceptable. Okay, that process going from 1.2, reading it up and across, that is called extrapolation. Okay, that is the process of reading a number up and across.